right, hello everybody, welcome back in. Today is Sunday, February 9th, 2025, and we are back taking a stab at Harvard CS50X 2025, week 5, problem speller. So we left off on speller yesterday. We yeah, we left off on speller. And so I did some research on this problem while I was away because it is pretty elaborate, and I didn't want to spend a bunch of time on stream trying to figure out what was actually going on behind the screen. Bro turned off the game. Was never watching it, Tim. I not much of a football guy. I used to like sports growing up, but I kind of just lost all that passion when I stopped kind of playing it myself, and I just was like, you know what, it doesn't really matter at the end of the day. So anyways, we left off on week 5 yesterday. We are gonna need some help. We're gonna need to band together, you guys, and try to solve this one together. This one is pretty elaborate. For the most part, it's just given a. It's got a lot of stuff going on here. So, right. So our goal we left off on last time was to load dictionary into memory, returning true, successful, else false, right? Because it's a Boolean function. We need to open the dictionary file. So we did that in reader mode here, right? We are going to read each word in the file. So rather than using read, I did some research on some other functions. I think we are going to use the fscanS function or fscanf function. So if I go CS50 functions here, go to the manual pages. Let's go fscanf. I haven't quite got the Pokemon cards yet. We're gonna implement that soon, but it sounds like you guys are interested in that, so that's good. Okay, so this function scans a file for values of specified types, expects an input as input the pointer to a file that was returned by a fopen, right? To get a single word sequence of non-white space characters, use the string character, but it's only safe to use this function to get a word from a file using %s if that word is some maximal length. For instance, if a file is a pointer to file, it was returned by fopen and buffer is an array of 3 bytes, this function can only get high, including its \0, but not high exclamation point, as follows. Okay, so instead of doing fread here, let's do fscanf here, and we need to take in the file that we're reading from. So this is our input, right? And then we're going to look for strings, and then we're going to apply this onto some kind of buffer. Now it says here that the buffer has to be of appropriate size. So this structure had a word which is length plus 1, right? And if we go to our dictionary H, our length is defined as 45. So let's go here to our speller C file, or sorry, dictionary.c file. We need to create a buffer. So what is this buffer going to be of type? Char star buffer. Right, because they're going to be strings, is equal to, no, we want to set a size of length plus 1, right, which is this same iteration for a word, right? We're wanting to get the word, and then we need to, right, So is it char star? Should we is the char star the appropriate type for this buffer? I'm not, I think I'm, okay, let's just keep going here. So what do we want to do? What do we want to do? Read each word in the file. Okay, so then what does it return? So we want to open the file. We want to say if input is equal to null, all right, we need to have this check here. We say return null. Read each word in the file. Buffer length +1 is full of strings. Gathering, right? Because that's, oh, it's just a char for a word. Is it a char? How's it just a single character? Okay. So then, let's go here to our load. Increment load here. So we add the file to the source. Cool. And then we also close with fclose the source here, like that, right? Okay. So what remains is to read each word in the file and to add each word to the hash table. Return true when the program operation is successful and false if it ever fails. Consider following this problem's walkthrough and continuing to proceed on. Okay. So I think it is beneficial for us to not waste, it's going to waste too much time trying to go through and figure out what this is, because I really don't know what's going on. So I do want to watch this walkthrough and have him explain. I kind of previewed it, and he doesn't give any code, which is nice.
In Speller,
so
your task is going to be to write a spell checker that can take a text and take every word in that text and check, so that by the end of it, you'll have a... Your first task in Speller is going to be to implement the load function, which is responsible for taking the dictionary and loading it into a hash table. How is this going to work? Well, the load function will take as its argument a char star, or a string, which is the dictionary file that you're going to have to open up and read from in order to load all this data into your hash table. It's going to return a Boolean value, true if you were able to successfully load all the data into your hash table, and false if there was some sort of memory error, like not enough memory available to allocate, for example, or a file that couldn't be opened. So let's take a look at how you're going to do this. Well, ultimately, when you open up this dictionary file and store all of the words in memory, you're going to store them all inside of a hash table. And recall that a hash table is really just an array of individual linked lists, and the way you determine which of those linked lists you're going to insert a word into is based on a hash function. A function that in this case is going to take input, a string, or a word that you're going to include in the dictionary, and the output is going to be some number that you're able to generate from that input, which is going to correspond to which of the linked lists you want to place this particular word into. Let's take a closer look at hash tables to get a better sense for how they work and how they're going to be useful for this load function. Here, for example, I have 5 words that I would like to store inside of my hash table: apple, banana, bat, car, and book. And I could take all of these words and just put them in a single linked list. But then I'd have a pretty long linked list of 5 words that I would have to traverse if I wanted to find whether any one particular word was inside of my data structure. Instead, I can put them into a hash table, creating several buckets, so to speak. I'll create an A bucket for all words that begin with the letter A B bucket for all words that begin with the letter B, and a C bucket for all words that begin with the letter C, and then associate each of those words with a particular bucket. So for example, apple ends up in the A bucket, bat, book, and banana end up in the B bucket, car ends up with the C bucket. What I've used here is a hash function, a function that takes apple or bat or book as input and outputs which of the linked lists, the A linked list or the B linked list or the C linked list, that I should place this particular word into.
Yeah.
So what exactly is a hash function? Well, a hash function in this case is going to take a word as input, and it's going to output a number corresponding to which bucket or element within this array we want to store the word in. Because recall that a hash table really is just an array where the very first linked list in that array is at index 0, and then...
Okay, so we need to write... So while fscanS reads this, what do we want it to not equal? What does it return? Scans a file. File was returned open. It specifies what with respect to zeros or more, each of which would be a location in memory. The format string should typically contain conversion. For instance, if the file is a pointer and %i. To get a single word, sequence of non-white space characters used, but if it's only saved to word. The function returns a number of arguments that were assigned values or end of file, a constant defined in standard I/O if the end of the file has been reached. Okay, so then let's say will fscanf only scan one string at a time within a loop? Let's ask that. Yes, fscanf can scan one string or one set of specified inputs at a time within a loop, depending on the format specified user for how it's written. If you want to read multiple strings or values per iteration, you can specify that in the format string. So char 100 scan while it doesn't equal end of file, print the string. In this case, it scans one string up to the next white space per loop. However, you want to adjust it to scan multiple values at once. First name, last name, scan file, we say while fscanf file %s, first name, last name, and age for the equals 3. You're going to do it 3 times. Okay, so let's see here. It's not equal EOF, end of file. So what do we want to do? We need to get a we need to get the word out of buffer, right? So why would this not be a char star for a buffer? Okay, so we need to call hash on the word inside buffer at this loop. So we'll say hash num is equal to hash on, so we have this hash function, right, which takes in a const char star word. So char star buffer length +1, so we're going to go buffer index 0 like this, right? So that'll take the word out of buffer, hash it, and return a value from that. we need to then make a node, right, in order to add that node to the hash table. So we need to go so let's first make a word is equal to buffer index 0 to basically just get that reference out of there. Word. We say, hey Frim, how you doing? I appreciate you for jumping in. We're doing some practice in C right now, trying to solve the week 5 dictionary or speller problem. This is in C. Thanks for jumping in. Hey Tim, hey Ellis Dominguez, how's it going? Will do, Mahan. We can talk after the stream for sure. Okay, so hash number, hash word. Okay, so that gives us a number. We then need to make a node. So node new node is equal to, hey Maesh, how you doing? Welcome. I appreciate you for jumping in and saying hello. What's going on? Hopefully I pronounced that correctly. Please let me know if I did not. All right. So node equals new node, where we set. So how do you make a new node? Node has a word. Okay, so we'll just make a new node like such. New node dot. So we'll, hold on. We need to make a new node, which is just but we need to allocate memory, right? We have to allocate memory first. So we have to go malloc size. Okay, hold on. We need to allocate memory for the nodes. We'll do it here. Malloc size of the node. Right, so now we're getting memory, allocating memory for this new node. We are then going to assign the new node. We need to deconstruct the new node, so, or dereference it. So star new node dot word is equal to word, and star new node. So we can't set the next pointer here yet. Hey, Notnil, how's it going? I appreciate you for joining and saying hello. We're just doing the Harvard CS50X week 5 right now. So the Harvard CS50X is a computer science course, and we're on week 5 right now, solving the kind of homework here. So we have a load word dot next equals null, just right off for now. And then we need to set okay, so what are we doing here? So do I need to reset my buffer, or I'm directly overwriting? Okay, so let's go back to our here.
1 and then 2 and then so forth. And so our hash function is going to take the word and output which index into that array we should use
that's right.
to place.
We need to generate we have a hash number here. So we need to go into our hash table here. So we need to go to our hash table. So table, we have a location in memory. So we need to dereference the table. Go maybe it's just table index hash num, right, is going to be equal to new node. Right? Add each word to the hash table. Close dictionary.
That particular word in. And at each index inside of the hash table is going to be a linked list. And what is a linked list again? We'll recall that a linked list is a way of storing data that's comprised of nodes, where every node has a value, as well as a pointer to the next node. So for example, in the case of our spell checker, we're going to have a hash table, which is an array of linked lists, and each of those linked list nodes is going to have a value, some place to store a word, which in this case is going to be a character array, which can store words up to the maximum length of any word, as well as a pointer to the next word. What does this look like? Well, if you look at the top of dictionary.c, you'll see the definition of constant integer, which is called n, which we've initially set to 1, and now said that table is going to represent our hash table, and it's going to be an array of node pointers, an array where every element in that array is a pointer to a node. Right now, this hash table has only one element in the array. In other words, there's only one bucket in the hash table. So you'll likely want to change n, set it to some higher value.
Wait, so we can't just insert here. We got to go to this location. The table is a node comprised of nodes.
So your hash table can have more buckets and therefore spread data out a little bit more evenly. Initially, though, your hash table is going to be empty. So how are you going to be able to add more data to that hash table? Well, to do so, you're going to need to allocate memory for a new node and then put some data into that node. In order to allocate memory for a new node, I might have some code that looks something like this. Node star n equals malloc size of node. Malloc here means allocate some memory, ask for some memory from the computer. And how much memory do I want to allocate? Well, size of node is going to be the number of bytes of memory that I need in order to store a node. And so malloc size of node is going to give me just enough memory to be able to store a node, and I'm going to store the address of that node inside of n. How do I then put data into that node? Well, remember that a node has two properties to it. It has the word itself, as well as a pointer to the next node. So I might say stir copy n arrow word, and then hello. What is this going to do? Well, stir copy is short for string copy. It's going to copy a string from a source into a destination. And in this case, it's going to copy the word hello into the character array n arrow word, which is
In error word. Okay, so we need to do stir copy here. New node word. Quote hello. Oops. Word. Like this. Right? Okay.
The word field of this node that I've just created some space for. I've copied the word hello into that space in memory. In order to set the next pointer, if I knew what the next node was, I could set it right away. But if I don't know, I could just set it to null. N arrow next equals null means right now nothing comes after this particular node. Of course, in a linked list, some of these nodes are going to have other nodes that are the next node in this sequence of elements inside of the linked list. So what exactly do you need to do now inside of this load function? Well, the first thing that you're going to have to do is open up this dictionary file. Next, you're going to read strings from that file one at a time, one word in the dictionary at a time. For each of those words, you're going to create a new node, some node that is going to have a value and a next pointer. And you're going to hash that word using a hash function to obtain a hash value, an index into your hash table to determine which of those linked lists you should use when you're inserting this node into a linked list. And then finally, you're going to take each of those words and insert that node into the hash table at the location given by your hash function. So let's take a look now at each of these steps one at a time. Let's start with how you're going to open the dictionary file. Recall that the argument to the load function is a char star or string representing the dictionary file that you're going to use for the loading. You can use the fopen function to open up that file, and then make sure to check to see if the return value is null to make sure that you were able to successfully open up the file. If you weren't able to successfully open up the file, your load function should return false. Otherwise, you'll be able to keep going to the next step of the load function. The next step is to read strings from the file. And for this, you can use a function called fscanf, short for scanning from a file, where the first argument is going to be that file pointer, the result of calling fopen on the dictionary file. The second argument is %s, meaning you want to read in a string. And the third argument is word, which is going to be some character array, some place where you're going to read the word into. In other words, some character array inside of memory, where you can then access all of the individual characters of that word after you've read it from the file. And you're going to want to repeat this again and again and again for each of the words in the dictionary, calling fscanf on the file over and over, getting one word at a time, until fscanf returns EOF. And that will happen once fscanf reaches the end of the file. So when fscanf returns EOF, that's your sign that you've finished reading all of the words in the dictionary. But you'll likely want to have some sort of loop that's running fscanf again and again on one word after word after word until you get to the end of the file. What are you going to do for each of those individual words? Well, the next step is going to be to create a new node that is going to store that particular word inside of your hash table. How to do that? Well, recall that the malloc function you can use to allocate memory. So you'll want to allocate enough memory to store a new node. And again, be sure to check if malloc returns null or not, because if malloc doesn't have enough memory to be able to store the node, it'll return null, and your load function should return false. Once you've created that node, you're going to want to copy the word into that node using the stirCopy function, a function which will take a string and copy it from one location into another location. Now that we've created the node, the next step is to figure out how it is we're going to insert this node into the hash table. Recall again that a hash table is just an array of linked lists, and we now need to determine which linked list we should use when we're determining where to place this particular node that we've just created. And to do that, we're going to hash the word. You're going to use the hash function, which is defined in dictionary.c, which will be a function that takes a string and returns an index, some number that you can use to index into your linked list. Right now, we've given you a hash function that just returns 0 for every particular input. And later in this assignment, we're going to replace this hash function with a better hash function. But for now, you can just call upon the hash function inside of load to determine which index into the hash table you should use when you're inserting this new node. Once you've determined which linked list you should use, the next step is to actually insert that word into the linked list.
Yeah.
How are you going to do that? Well, again, recall that the hash table is an array of linked lists, and you're going to want to index into the hash table to get the linked list that you want to use to add this particular word into. And in order to do that, you're going to have to add a new node to a linked list. So you'll want to be sure to make sure you're setting your pointers in the correct order. What do I mean by that? Well, let's take a look at an example. Here up at the top, imagine that head is a variable that points to the start of a linked list.
Yeah.
The linked list is bat, and next is book, and next is banana, and banana here points to null, for example. And let's imagine that I have this new node, which is this blue node that I've just mallocked, and I want to add it to this linked list.
Yeah.
So if I wanted to make this new node the new head of the linked list, one thing you might imagine that I would do is point head to point at this new node that I've just created. But what's just happened? Now that I've set head to be blue, this very first...
Okay, I get it. So we need to go to this location, right? We need to point to the dot next. If table hash dot next is equal to null, meaning that this is the first time we've seen this value, then table index hash num dot next is equal to the new node, right? Else, right, it's not null, we have a value there. We need to save a temporary value as the current next value of the table node hash. Table hash num dot next, right? We then set this here, right? And then you need to set the pointer of new node that points to temp. So then new node dot next will equal temp. Hey Levi, how's it going? Welcome back. Thanks for joining me here. So we do need to figure out though what these pointers are, because we're not accounting for that. So we're saving the current next value from the hash if there is a next value. So we'll dereference new node dot next. Do I have to dereference this value too? Maybe, I don't know. Yeah. And then dereference it here as well. It's a pointer. No, to a place in memory. I want to get the head node, right?
Node inside of this linked list, just this blue you can inside of in the dictionary. Reading that word using fscan.
Okay, so now what? Let's take this guy over here. So is that the end of this function? Close. So we need to return true if this is, if all of this works. Okay, so let's, I'm gonna take this, let's go over to the debugger here. I'm gonna say, actually let's say first, where should I return true within the load function? Do I can't tell you exactly what you remember, but I can help you think through the load function. We want to return true if the dictionary was successfully loaded into memory. What conditions would indicate the dictionary was loaded successfully? So can I say, like, out front here, can I say return val equals here bool? Hey Eric. No, not really. I don't really care for football too much. I've had my heart broken too much in the past, growing up as a fan, that I just kind of faded out of it. Plus, growing up where I grew up, we didn't have an NFL team in our state. Return value false. Return val if this is successful. So if this is unsuccessful, return false here actually. Then let's get rid of this actually, and then return true here. Okay, I'm going to take this guy, paste it in here, see what he says. Let's go through your code together. I see that you're opening the dictionary, reading each word, and adding them to the hash table. That's great. Now let's think about when we should return true. We want to return true if the dictionary was successfully loaded into memory. What conditions would indicate it was opened properly? Yes, and opening the file is properly is one condition. We also need to make sure that we've read all the words and add them to the hash table. Do you see any other conditions in your code to indicate the dictionary was loaded successfully? So we'll say else if here, and we'll say else return false, like that. Can I change my current else to an else if, and then add an else below to return false if neither if statements were true? It sounds like you're thinking about handling different cases. Remember, if you want to return true if the dictionary is successfully loaded into memory, if there are any specific conditions indicating failure, you want to return false. In your code, you already have a check if the file cannot be opened and return false, and on the other conditions, you would indicate failure. So if the hash number is greater than 26 or 25 or less than 0. And if what about the process of reading words and adding them to the hash table? Okay, let's try to do the check 50 to at least see if we have the appropriate reading of a dictionary going on. I think we can at least kind of see that. So let's throw this in here. Let's see if we at least have the, hey, Insomniac, how's it going? Welcome. Welcome back. Stream's kind of slow tonight. People must be watching the game. All good. It doesn't compile. Okay, so I'm not even compiling. Okay, hold on. I have a compile error, so I need to see why I'm not even compiling. So let me go here. Make speller. Oh boy. So load, stir copy. Word load here. Include string.header. Dictionary.h. Include .h. Okay, we're getting errors here. A word. Um, mm, 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 mm. Isn't like this. We take this guy, throw it into the duck, see what it has to say about it. Looks like you've added else statement false if neither of the previous statements are true. However, remember that if we want to return true, the dictionary stays loaded into memory. You're reading each word and adding them to your hash table. You can return true at the end of the function. That would indicate failure. Where indicate failure? If let me see here. Let me prompt you here. I am working on a problem. Do not show me code, but please walk through, or please provide feedback on my current, right? I can give you a few suggestions. Buffer declaration and usage. Char should be char. Buffer length. You want a single buffer, not an array of pointers that can hold each word. Okay, not an array of pointers. We want a word. Okay, so a single char. Oh, we need to remove this semicolon. And then we have char word. or star, because this is trying to read a string though. So we're trying to access the word. And then it says that we have some issues with our current hash assignment. So we're currently saying table hash number next equal null. Temp table hash. So it doesn't want us to be using pointers here for this. Or this, because it is a list of pointers already. And we need to point this one though. And this should be input because we used input from before, right? Okay, but also we need to determine the new node if we have memory. So if new node is equal to null in memory, we need to return false, right? This was unsuccessful. But what is going on with this? Why are we getting table here? Okay. If the memory allocation was unsuccessful. Yeah. Okay, so now let's throw this guy in there. It likes it now. Great, now you've checked for memory allocated failure. Now let's look over the rest of your code. I see that you're using buffer to store each word in a file, then copying it into a note. However, it looks like you're trying to assign buffer 0 to a word, which is a single character. Remember, buffer is already a string, so you can use it directly. Buffer is already a word, so you can just use it directly. Do I need to clear the buffer after each iteration? And C, you don't manually need to clear this buffer after each iteration when you use fscanf. Read it to a buffer, it will automatically overwrite the previous contents. Okay. Cool, so then I can see here, let's take this guy into the almighty orb. Please don't show me code. Do I have any syntax issues? Let's see here. Yes, here we go. So this is going to be an integer. We have node table. And temp are undeclared. Hash number and temp are undeclared. So temp is undeclared here. So temp should be a pointer. So this is going to be a node pointer. This should be just assignment. This should be assignment. That's what's going on here. Else node. Why am I getting some errors here? Else if needs a condition. Okay. Yeah, we need a condition here. That's why. Right, does not equal null. Right, like so. We'll do that. And then we don't even need an else block. And we don't even really need this. So now I'll take this guy, throw it into here. Let's see. What do you say? You've made some great improvements. You still have some issues. Try running your code with some test cases. It's going to help you identify specific problems. If you're still having issues, feel free to ask. Okay. Now, will we compile? No. Well, is there some specific way we need to run this? Like, what's how it's asking here? How to test. So check whether your program's outputting misspelled words. The answer keys. All the words your program thinks are misspelled. Therefore, you should run your program in just one window. Okay. Ensure the table is correctly initialized and node has a word array large enough to hold word. Check if table hash number is a proper pointer and won't create a circular reference. Okay. So I think, are we done with this function? Okay, so then what would be our next function? Implement hash. Complete the hash function. Hash should take a string word as an input and return a positive unsigned integer. This hash function given you returns an integer between 0 and 25 inclusive based on the first character of the word. However, there are many ways to implement a function beyond using the first character or characters of a word. Consider hash function uses some of ASCII values of the length of a word. A good hash function reduces collision and most likely even distribution across buckets. Okay, so we probably don't need to change this function, but we could implement a better hash. So what about size? Complete the size function. Size should return the number of words loaded in the dictionary. Consider two approaches. Count the words as you load them into the dictionary. Return the count when size is called. Okay, so then we need to implement size. So where is size? Check size here, unsigned int. Returns number of words in dictionary if loaded, else 0 if not yet loaded. So the size of the dictionary. So we're opening up the dictionary and loading in the dictionary into memory. So then we can count words within this. Complete the size function. Count each time size is called, iterate through the words in the hash table to count them up. Return that count. So size would be count each word as you load into the dictionary and return the count when size is called. Let's keep watching here.
When you're loading words into your dictionary, and when you're checking to see if a word is spelled correctly or not, you're going to need to call on your hash function, a function that's going to take a word and return which index into your hash table.
Let's go forward one more.
In the size function, you'll need to return the number of words that are in your dictionary. There are a number of ways you might do that. You might imagine iterating over every single one of the linked lists inside of your hash table, counting the number of nodes inside of each of the linked lists. Or you could imagine that as you're loading the hash table, you could somehow keep track of the number of words you've added to the dictionary so far, so you can return that value in your size function.
So then how can I within this function, my load returns a Boolean. So can I make a global variable out front, basically? Let me make, right, we'll say, dict word count. Hey, Slow, how's it going? Appreciate you coming in. We're definitely gonna need your help here. This one's pretty elaborate. So we have a dict word count, which is gonna be int dict word count equals, right, equals to 0. As we load words in and add them in, right, we're gonna go dict word count plus plus here. Or just we'll command C, shift command, we'll take this command X and we'll just put this at the bottom of our while loop to do it at each iteration. So this will return dict word count unsigned int. So then we need to go here and go unsigned int that, starting from 0, return dict word count. Okay, I think that'll work. Implement check. Complete the check function. Check should return true if a word is located in the dictionary, otherwise false. Consider that This problem is also composed of smaller problems. If you've implemented a hash table, finding words only takes a few steps. Hash the word to obtain its value. Search the hash table at the location. Check specified by the word's hash value. Return true. Return false if the word is not found. To compare two strings case insensitive, you may find the string case compare declared in strings.h helpful. You'll likely want to ensure that your hash function is case insensitive so that foo and foo have the same hash value. Okay, so then in our check, we're taking in a char star word, constant char star word. We are going to go hash the word to obtain its value. So int hash num is equal to, what does hash return though? Does it return an int or unsigned int? Unsigned int. Unsigned int. So unsigned int. Yeah, right? It's a lot of reading. This problem is really, really long. There's only 2 problems this week, so it makes sense for only being 2 problems, but it is a long one. I started it yesterday, and I already finished one of them, so I was kind of burnt and didn't want to dive into this one. So we're giving this one a go today. So we need to, in our check, hash num is equal to hash on the word, right? We're going to say table hash num. We're going to index into table, go to the hash number, okay, we'll say, which is the head node. So we'll say while table hash number dot next does not equal to, so while stir case compare table next and word is not equal to, let's go back here. What does that one give us? Stir base compare, stir case compares 2 strings ignoring case. If an int is less than 0, 0 if S1 is the same ignoring case. While does not equal to zero. When it doesn't equal to 0, what do we want to do? While stir case compares table hash number dot next and word does not equal 0. So So we'll say return val equals false. Return val. Right. While it does not equal 0, okay, no, hold on. While this does not equal to word, this is node dot word So we want to access that index in memory. We want to dereference to get the word, right? And then we want to compare it to the word provided in the function. While it does not equal 0, we're going to set word check is equal to table hash num pointing to word, right? We'll call this word check, and we'll set word check equals to word check dot next. So we'll say, hold on, we say though, if word check dot next word is equal to null, right? We're going to return false. Else, right? Else we're going to just going to call next on the word. So, right, we're first setting to check, given a word, we're trying to check if this word is in our hash or not. So we're obtaining a hash number from this word. We are assigning it an unsigned integer, which is what the hash function returns. We then get a word to check, right, a word to reference against. So we go to table hash number, right, and then the pointer to that word, because this is a node. So this is going to be a node like this. But then we're gonna go to because this is already a pointer. So then we go word check word node word equals word check like this. All right, so we're gonna get the current node at this in our current hash table. We're going to get the node's word, right? While the word does not equal isn't 0, we're going to call next if word check, which is just the word. So if node dot next word is equal to null, return false, meaning that we didn't find it, else call next on word check. It's gonna be so we need to override word check to be the node.next So let's actually go like this. Let's make this char star dict word is equal to this pointing to a word dict, right? This is going to be dict word, given word equals 0. If it doesn't equal to 0, if the next word is null, return false. Return true here. So how about we say if it's equal to 0, return true. No. While it doesn't equal to 0, we want to call next so dict word is just a word currently. So if it doesn't equal 0, meaning these two words are not the same, we want to move forward to the next word in our linked list. So we need to go, but we're not providing a node here in this. So we don't need to compare here then. We need to compare while node pointer word so hash number, this will give us then we need to bring back our node, right? So node star dict node, while the dictionary node, while dict node, right, dot while dict node word does not equal to null, right? We're going to do the stir case compare of word and dict node pointer word. If this, right, we're going to do the comparison. If this is equal to 0, we want to return true, right? Meaning that so if the word that we're given and the node that we're currently on in the dictionary, that word is 0, the return of this function is 0, return true, meaning that these words are the same. Else, they're not the same, right? So we need to set dict node is equal to node dot next, like that. And if you don't get it at the end of this function, you return false. Okay, so what's going on? First, think about how to traverse the linked list at index you got. Then you can compare node at the current position on the linked list. Forget about the words for a moment. Only think about the traverse the linked list. It should be easier to reason that way. Yeah, so, right, we are accessing the current node at that index, which is the dictionary node within our table. While this node that we're currently on, this dictionary node, that word associated with it does not equal to null. No, this should be next, sorry. While the next position does not equal to null, we're going to check the words. If they equal to 0, we're going to set, if they equal 0, return true. Else we're going to set the dict node to the next dict node in the linked list and continue the iteration. So I think that is appropriate. Let's go ahead and throw this in the debugger here. Check function. Do you have any specific questions with your code? Do you see anything wrong? Let's take a closer look at the code. I see that you're using the while loop to traverse the linked list at the hash index. However, remember that the last node in a linked list has a next pointer that is null. So you should check if the dict node itself is null to avoid referencing a null pointer. Thought I was doing that within the while loop itself. While dict node next so we just say while node does not equal node, go forward. Right, so we can just do that. Oh. You fixed the while loop condition. I see one more issue. When you update the dict node in the loop, you should use the you should use the pointer operator instead of the dot operator for dict node as a pointer. Oh, yeah. Right, the next. Right, like that. Because dict node is a pointer here, and the next position is a pointer itself. This is just a part of the CS50 course. This is their debugger. It's a kind of tame version of AI that doesn't really give you code, or you have to really kind of prompt it questions for it to give you feedback to kind of help eliminate cheating and things along those lines. But you know, you can obviously throw things into AI and help give you more information. But I highly suggest you specify. Please don't show me code so it doesn't spoil things. Like I went over here and I'll chat in here. I'll say please don't show me me code, but tell me if I have some syntax issues, and it'll tell me, oh, online you might want to check line like 10 and on like this thing and see if it, and that way you can kind of come up with the answer yourself, but just be guided into a narrower scope of where those errors might be. And I found that to be really helpful, helping you learn. Okay. So now let's throw this in there. It should like this. Nice. All right, cool. We're moving up. I think that one's done for the check function. All right, next up is the unload function. Complete the unload function. Be sure to free and unload any memory that you allocated in load. Recall that Valgrind is your newest best friend. Know that Valgrind watches for leaks while your program is actually running, so be sure to provide command line arguments if you want Valgrind to analyze speller while you use a particular dictionary and or text as in the below. Best to use a small text though, as else Valgrind could take a while to run. Okay, so we need to do unload here. Okay, so let's see. Let's go forward here.
In the check function, your job is to take a word.
Unload here.
The last step to completing your spell checker is to implement the unload function, which is responsible for freeing up any memory that you've allocated in the process of running your spell checker. What does this mean? Well, remember that anytime you dynamically allocate memory using malloc, it's also your responsibility to call free on that memory to free up that memory and give it back to the computer. So what is your unload function going to do? Well, your unload function is going to call free on any memory that you've allocated using malloc and return true if it's able to do so successfully. How are you going to do that? Well, remember again that your hash table is really just an array of individual linked lists. Each of those linked lists contains nodes that you have allocated memory for, likely using malloc. So you'll need to free each one of those nodes. So you might imagine iterating over your hash table, going over each of those individual linked lists, and calling free on all of the nodes inside of those linked lists.
Okay. So how could we do that? We could say, so we know that our hash table is table. Say, so for int I right equals 0 while I is less than n, I plus plus. Okay, we want to do this. We're going to access the head, so this is going to be table index I dot next. So this will be the head. So this is going to be a node table index I so we'll do the same thing. We'll say while, hold on, we need to go while node table index I. So that's the table index I is a pointer. So we need to say, well, back in the check I said, while dict node that we're currently on. Okay, okay, so the node that we're currently on, so we'll say node star dict node is equal to, because my check I did node star, yeah, okay, got you, perfect. So dict equal to table index I, while the dictionary node next pointer does not equal to null, right? We want to free dict node call dict node equals dict node next, and then while the dict node itself does not equal null, not next. While the dict node itself, because we're calling next here, right, we'll continually go increase I for all of those places, and then we will return, we need to return after the loop, we need to free table as well. That's right. You're right. Thank you, World Challenge. So we need to save temp variable, which is going to be a node to a pointer, is equal to dict node. We're going to free dict node and then call temp next is equal to dict node. And then we'll free table at the end of the for loop, because we cleared out the table, and then we will return true here. Okay, so now let's throw in this guy into here. Let's see what it says in here. Looks like you're working on the unload. Do you have any specific questions? How do I look so far? Your code is looking good. You made some good progress, so I see some small issue. Remember that you should free the temp node after updating dict node. Okay, right, that's right. So then free temp as well right here. GC or let me change, yeah. Hey Ryan, what's going on? Welcome back in. What are you working on this evening? What are you studying? Welcome back. It's awesome to hear from you. Oh, wait, hold on. So we need to... free temp node outside of here. Remember that you should free temp node after updating dict node to that. Right, outside of the loop. You move the free outside. I see one more small issue. Remember that temp node after, okay, hold on. I see one more small issue. Remember that you should free temp node after updating dict node to temp next. What's the score of the Super Bowl? Is the Chiefs winning? Is that why you're sick of it? Oh my gosh, they're getting smacked. Holy cow. 34-6? Woo! Down goes Mahomes. The three-peat is no more, right? Is this the three-peat they're going for? So your code is looking better. You moved free temp statement outside of the while loop. I see one more small issue. Remember that you should free temp node after updating dict node temp next. First set temp node, then update node to next. I set temp node. Oh. Wait. I set temp node. To dict node. I'm updating dict node, but I free it here. So like this. Remember that you should free the temp. Remember that you should free temp node, not dict node. Oh, so just delete this altogether? Then do I free the dict node outside of the for loop with table? You should free each node in the linked list. You can do this by freeing temp node inside the while loop. Hey, Trash Ketchup. Yeah, this problem is a little bit hard to kind of wrap your head around. It's not as hard as the Tideman problem, but it has this similar kind of formatting to where you need to read all of their code base and see what's going on. So it does have a little bit of a curve. Looks like it was the refs after all. You're talking about that. And don't they have accusations of always getting just... So free temp here inside of the for loop. So we create temp as dict node. We save temp next, overriding. Wait, what am I doing here? So I'm creating a temp, which is a dict node. I override it with the next value. And then I need to call wait, what happened? I feel like I deleted some more stuff. So I save temp as the dict node that we're currently on. I override it with the next value, and I free temp here. And then do I free the dictionary node outside of this? Do I have to finally, or does the table free it all? After the for loop. I am freeing it after the for loop. I don't want to free it. I want to free it after I go through all the way. Let's see where I have some syntax problems. Yeah. I free table at the very end. Right? Just like I'm doing. I am freeing after the for loop. Oh. Is that literally it? That all it wanted was that? Okay, so now can we go like this? Let's try this one. So how do you run again? Make automates. What do we have to type in here? So my dictionary. I'm importing string H. Is there a difficulty associated with each problem? No, not really, but they can be a little bit difficult for like new beginners. They are pretty elaborate. I highly suggest you take a stab at Harvard CS50P if you're just starting out. It's a lot more simple with the syntax, with the problems, and then they help compound into this CS50X from there. So if you're looking for a place to begin, CS50P is a great place, Sam. So how do we test this thing? Speller dictionary small. No such file or directory. Dictionary small text. What? How do you spell it? Do this. And lastly, recall that make automates compilation of your code so that you have to execute Clang manual along with a whole bunch of switches. However, if your program grows in size, make won't interfere with context. Blah, blah. Your first line tells make to execute. Be sure to compile speller by executing make speller. Just make. It's called to undeclared function stir comp case comp. Dictionary.c. Okay, so let's add in here, I guess. I thought the dictionary would work because we're including dictionary.h, but I guess it doesn't. So string.h. I'm including it here. It's clear. Make. Undeclared function stir case comp. What? Stir case compare. Strings.h. Okay. Oh my gosh. Strings.h apparently. Thank you so much. Strings.h. So we'll remove that from here. And then let's try that one more time, I guess. Make. Okay. Failed again. Use of undeclared identifier null. Oh boy. We need string.h2. Where'd you go? Come on. Come on, don't do that. Where'd you go? It's over here. Here we go. We gotta go here, go include string.h. Include called under malloc standard library. Okay. All the I don't know why didn't it include all this stuff for us. stlib.h. std. Oh, standard library. Oh my god. That's 70 table hash. Next. Oh my god. Come on. Attempt to call free on non-heat object table. attempt to call. Your error message indicates that the table array is not a heap object, so it cannot be free memory. You should only free memory that was allocated with malloc or calloc. You remember how table was created? It was just an array of n size. An array of nodes of n size being 26 by default for ABC for alpha betical buckets. It sounds like the table array is a global variable that's not located with malloc. Okay, so we just delete this line here because we didn't actually use malloc to create table. So now if we go make, oh boy, we made finally. Finally, guys. Oh my gosh. So many errors. So many errors. Okay, let's keep going here. All right, let's throw in something here. Speller text La La Land. Oh. Oh gosh. Well, where's the check 50 at? Let's take this guy. Segment fault. Oh no. Oh no. Oh no. Where's check 50 at? Let's take this one. Does this one work? No, nothing works. Oh gosh. So segment fault meaning that we have infinite loops going on, or what does that entail? No, nothing right. Oh my gosh. Well, it can't even it compiles, but it gives me this segment error. Okay, so let's see what we got going on here. So touching memory that can't be touched. Well, how do I know where I'm putting my grubby little hands, or they shouldn't be? That's the question. There's a good explanation of segment faults easily searchable. So let's go to the debugger here and say, I'm getting segment faults. This is where the programming tries to act memory that it shouldn't. Do you have a specific error message that points to your code that may be causing the segment fault? No. That's okay, let's try to narrate it. One of the common reasons is dereferencing a null pointer. Do you see any places where your code might be doing this? It's got to be within this load function here. That's got to be the only place it is, like in terms of this is my load function. Do you see anything wrong with it? You made some progress. I see one small issue. Remember that you should initialize each element of the table array to be null before using it. Do you see where you can make this change? So table index 26, right? How did I do this in my other one? I did this before. Hold on, let me see, let me think. I did this not in that one. In here. Where did I do this at? I already did this before. So what am I looking for? I'm looking for how to default all values to a certain one. Is it substitution? Here. Yeah. Okay, make all of the array equal to null right off the jump. Okay, so then can I go table uh, 26 default equals to null. This is a reference to those objects though. So if I put this here, will that recovering stamina? Oh, get out of here. Come on. Unhelpful. We're learning here. Why are you recovering stamina? Just stupid feature. So will this even work then? Line close to finding initializing a hash table. Node table declares an array of elements where an element is a pointer of a node structure. This array represents each table initialize each element the array to be null, meaning no linked list it exists yet, ensuring that all the pointers in the hash table are initially empty. Okay. So we initialize it all to null at first. So then in our thing here, if we go make hold up. Still have this table here. CD. What? Oh my gosh. Annoying. An array initializer must be initializer lists. Okay, so then let's just do it in the function then, I guess, whatever. Let me take table n. So in the load, table equals null. How can you set a table or a array to have all null vals? A for loop. Okay, whatever. For int I equals to 0 while I is less than n, I increase. Each time we'll set table index I is equal to null. Okay, that'll take care of that. Now what happens if we go speller, open here, make, oh, not is equal to, is just equal to. Like so. Oh, I don't have comma. Using a comma instead of a thing here. Man, I suck at C syntax, let me tell you. Let me tell you. This is rough. Okay, we made there. Okay, let's see what we get. Speller. No. Oh. Try any example inputs and run with debug 50. Okay, let's try that. Do they have a debug 50 example here we can use? Hope 50 val grind. Looks like your program is trying to access areas of memory that it isn't supposed to access. Did you try to change a character in a hard-coded string? Are you referencing it? Okay, so where is it? Does it give me the line? Does it give me a line that I failed on for trying to access areas of memory that it isn't supposed to? Did you try to change a character in a hard-coded string? Are you accessing an element of an array beyond the size of the array? Are you dereferencing a pointer that you haven't initialized if you freed it? Hi, Michael. Is the inheritance file you were working on, is this the inheritance file you were... No, we completed that one yesterday. This is the next one called Speller. The inheritance one was actually pretty easy. I whipped that one up pretty quick. If you kind of understand now, we had to first, understand the actual, we had to kind of do some connecting and learning because I didn't have a full grasp of what was required for, reserving memory for size of structures. So we had to wrap our heads around that. But once we did that, we were able to fly through that one pretty quick. You can just use the random function that's within the CS50 manual pages. They have a random function to generate the alleles, the random integer or the index of the allele. So okay, so where am I doing stuff that? So what did I change? So in my check function, line 13, calling next. So while dict, True, false. Leak summary definitely lost. For still reachable. Point results are still reachable. I don't know what any of this means. So let's just check these functions, I guess. So in check, what are we doing? I'm hashing the word, getting unsigned integer. Accessing node, well, this does not equal to null. Turn false. So that should be fine. Let's throw that in there. This check is a part of dictionary implementation. Let's break it down. Unsigned int. This function takes a string, integer, node. Wow, this loop traverses if inside the loop. Turn false. In summary, this function efficiently checks if a word existing is part of a larger. Okay, that one's fine. Like this debug 50 speller check. Okay, let's try that one. Okay, let's try it. What do we want our breakpoint to be? If new node is equal to null, return false. Stir copy new node word. Node next is equal to null. Add each word to the hash table. Unassigned int hash word. If table pointer next equals equal. Else node pointer to temp equal to table hash next. Hey, Naughty Sanus, welcome. How you doing? You're learning Java. That sounds interesting. What got you into that? So let's take this function in here, bool load. Say I am leaking memory somewhere or accessing it improperly. Do you see anywhere where I may be doing this? If so, don't spoil it. Try to guide me. Okay, you can see a couple places where potential memory issues may arise in your code. Let me identify some. Initialization of the hash table. You're initializing a hash table at the beginning, but this is only setting the pointers to null, not allocating memory for the nodes at each index. This could cause issues when you try to access table later on because... Okay, we already are doing that above though. Assigning table hash number. In this section, the code, you're trying to add new nodes to the hash table. Assigning table hash What's going on? Come on. Okay, stop. Can't even type. This mouse sucks. In the section of the code where you're adding new nodes, you're checking table hash next equal to null, but table itself is not guaranteed to be allocated as mentioned above. Overwriting memory elsewhere. Also check if the new word you're copying has a valid string. Ensure that the buffer is correctly terminated. Linked list management. I think that's line edit. You're accessing table hash number, but it could be null. In line 84, but I say if it is null, okay, but it could be null. But it could be null. Right. I'm defining linked list as this though above. You've already done the load function, but you need to ensure that the node itself is created, correct handling a linked list. If table hash. Okay, so we need to say if table hash so if we have a hash table so this would say line 84. So say if table hash num is equal to null, right? We need to assign some memory for this. So malloc size of node, and this is going to equal a pointer of type node pointer we can set it to just table hash number, right? Because that is a pointer already, right? We'll do that. Now, if we can't allocate memory, right, so we need to say if table hash num is equal, in this case, to null, we're going to return false here, right? To be honest, I think you can also do if not table hash number and not table hash number dot next, because null is just 0, which gives us a false C value. Okay. So if table hash. So we have to sign memory. If we go to the next value on our, and that is equal to null, we'll sign it. Okay, so now what does that do? Do you have any? Let's make. "38 errors. Words misspelled, words in dictionary, words in text, times loaded." Looks like you're trying to use a variable that might have a value. Take a closer look at 993. If not pointer, yeah, okay. Like right here, if not pointer, return false. You look, you're trying to use a variable that might not have a value. Take a closer look at line 93. So if table hash next equals to null, so if it equals to null, what do we want to do though? That's the question, is what do we want to do? If it equals, so we already, if the current index on the table is null, we're going to allocate memory for it as a pointer. Right, so now it shouldn't be null, it has memory. So let's take this load, bring it into the duck here, see what it has to say about it. Your load function looking great. You made some great progress. I see one small issue. Remember, you should initialize each element of the table array null before using it. You see where you might make this change. I already am doing that here. What are you talking about? This debugger is kind of stupid. Your updated function is much quickly checking if it's null by allocating memory for it. However, it should only be the first head node of the list instead of allocating a new node. Or you should allocate it the first time the word hash, and you can avoid. So we have, if the table hash is equal to null, easy sky, it's gross. Table hash, so null, return false, table hash next. Initialize it to be null. So we want to set table hash dot the next pointer to be null here. And then we don't do an else statement. We'll come out here. Oh, hold up. Hold on. Temp, pointer next. Table hash pointer next equals new node. New node pointer next. I'll just get rid of this syntax. It doesn't like it. Just temp. If the next node is equal to null, right? Else, like so. I'll take this, bring it into our debugger here. Looking great image, but I see some. We should. I feel I am at the beginning in lines 55 and 50. I did at the start. You're right. I see that you initialized at the beginning of the function. Take a look at the you're allocating. I noticed that you're allocating memory for. I'm running out of real estate on the screen. Let's take a closer look. I noticed you're allocating memory for a new node in the table array if it's null. However, since you already initialized table array to be null, you don't need to allocate memory for it in a new node in the table array. What? So we have int I equals 0 plus plus. Table I is null. We gather our file, we open it. If it's null, we return false. We have a character, char buffer plus 1. We scan buffer, new node pointer, malloc size as. If new node is equal to null, return false. We call stir copy the new node which points to word with a word, and we set the next of this value to be none, null. Unsigned integer hash word. If table hash equals null, table hash malloc size of node. If table hash equals null, free node so we need to free new node here and f close it's wanting our input. Table hash if table hash then we don't even need these checks. It's wanting just here on the if that's not true, do this. Okay, so now let's try clear this out, make semicolon. before. Gosh, I suck at this syntax. Oh my goodness. Looks like you're trying to use a Brillo in like 33. Stir comp word. Dict node. Okay, what happens if I... Okay, that got me something here. Total misspelled words, total words, words in text. Okay, now let's see here. Let's try to run check 50 here. Where are you at? There you are. Let's see here. We got some output now at least. Oh, we're really close. We're so close. Program is free of memory errors. See log for information. Ah, shoot. Okay, we're really close. So we just have this Valgrind error going on here. Is a variable that might not have a value. While dict if dict node word equal to null, would the word be equal to null? But I thought I'm doing that check here. Unless you have a check for dict node is null, however, since you're adding it, it should never be null. I am getting a memory leak with that if stir case comp line. Yeah, because this shouldn't matter because we're never gonna hit null. Memory leaks can be tricky. Let's try to figure out. And the stir case can cause memory leaks if it doesn't allocate any memory. Have you checked if all memory allocations are allocated? Your unload function. It's telling me to check line 33. It looks like your error message pointing to an uninitialized value in your code. The error message mentions a condition jumper move that depends on initial uninitialized value. This means that if a variable is being used in a condition like an if statement before it has been given a value. Okay, so I need to go char dict node to word. Right? char word 1. So can I say, do I need to declare the pointer as pointer to word as a variable before the if? And so you don't declare pointer as a word when it has been initialized to a point a valid memory location before using it. If your check function using dict word if statement, make sure that dict node word has been initialized before to point to a valid memory location before using it. If word, if not word 1, turn false. Looks like you're trying to store it in a variable called word1. However, dict node is a string char star for type. Okay, yeah, it's a string, so it has to be a star. So now if we go make 50 val grinds, line 38. Do I need to do a check on word? Do I first need to check the word? If word do I need to, if not word, return false? Line 42. What do you want? We'll check. There's a couple small points to review. Null check for word. You can handle this case for word, which is good practice. Null pointer check. You check if the word is null, but ideally the word or linked list dictionary word should never be null. If it is null, something is wrong with the data structure or memory management. While it's not strictly necessary to check since it would be happening as extra safety layer in case, however, this might be a redundant check. Okay, so we don't even need this. Like we did before, iterating through them. Unsigned int. Well, unsigned int hash number. No dict node hash table number. While dict node is not equal null. Is case comp word dict node pointer to word equals to 0. Return true. It does not like this. So you're using a variable before it has been initialized with a value. This can happen if you're reading from before they are used in logical statements. So word 1 is equal to dict node. Word. Oh, hold up. Node word. We don't need to override dict node, we need to override word 1 equal to dict node dot next word. Oh, shoot. Word declared here in the start. Compare word word. Comp word equals dict node I need to declare this as a char star, like so. Valgrind. No longer being displayed. More than 100,000 errors detected. What in the world is going on? Oh gosh, I broke it. Oh, now we're really failing stuff. Oh my gosh. So my bool check here. So we need to check if dict node pointer next pointer if so we'll just keep histrcompt while dict node is not equal. We'll delete this dict node points to word node next pointer. Are you checking null checking dict node next. Yeah, that's what we need to do right now, right? So if this becomes null, if dict node turn here. Line 38. What was the shortcut you used to delete letters starting from front of word? What do you mean? What was the shortcut you used to delete letters? In what setting are you talking about? Like, what problem are you specifically referring to, Von Trell? Hey, Hardcoreism, welcome. So I'm gonna go here like this. Issue is unsigned int. If not word, return false. Unsigned int node. While dict node is on a strict has return true. Dict node. We don't even need this. Looks like you're trying to use a variable that... What is going on? What is this? Variable is being used in a conditional statement in some other place where it has a value that hasn't been assigned or initialized yet. Based on the line 38 you mentioned, it's likely related to the variable that's being used in a comparison or logical condition. To help resolve this, I need to see the code around line 38. This is line 38. This is line 38. Seems to stand process initialized value of dict when you try to use this. Here's a step to issues. If dict node is null, then attempting to access a word would result in undefined behavior. So then we just need to do a check here on the dict node. So if dict node pointer to word is equal to null, we need to return false or break. So now if I make what is going on? Why? This is so frustrating. We're so close. Just come on. Comparison of array word equal to a null pointer is always false. What? Compare dict, which is not valid because dict node a word in an array, not a pointer in C. Not even compare. Why is it a pointer in? wants me to use the first character of the word is equal to the null terminator. What do you say if not? Oh my gosh. What is going on? Node. I don't get what's going on. What is this? Is the table an array? Yeah. Oh my god. Okay, I'm going to the debugger here. No, this is a good check. We gotta keep in mind. Check it. This is a good check, but keep in mind that check function is only called with valid words, so words should never be null. I keep getting this error. I keep getting this error for this function. The error message suggests there might be an uninitialized value in your code. The error points to line 41. Could you show me that part of your code? The error message suggests that there might be an uninitialized value in your code. The error suggests that is line 40. Oh my gosh, this is so frustrating. Like, this debugger is honestly stupid. The error message suggests there might be an uninitialized value in your code. That is line 41. In this line, you're comparing word and dict word using strcomp. Do you think either of these variables might be uninitialized? So do I just really have to go like this? Do I just have to do this? Looks like you're trying to store a dict word in a variable called word1, however. What? Where's word1? I'm not using word1 anymore. What is going on? Hey, Hysterical Mafia, how's it going? Oh, char star. So I need to initialize this. But what do I give it a variable name? Oh boy, this is getting annoying, everybody. Ugh. Structure or union. Char star word. So, line 41. Char dict pointer to word. T. Oh my god. The conditional jump or move depends on initialized values. Warning indicates that you are using a variable without properly initializing it. Based on your code and what Help 50 is pointing out, it's likely that the check function you're using a dict node word without being sure that it contains a valid string. Check load function. Ensure that every node's word is properly initialized. When loading words into a hash table, you might be leaving dict node word uninitialized or copying incomplete data into it. For example, in your load function, stir copy node. This ensures that the word is properly copied into the new node word. If you skip this step, what are you talking about? While dict node is not equal node, if dict node pointer to word index 0 is not equal to the null character and stir comp word dict word turn true. If you want it to improve it, you don't have to, I don't think. Use of undeclared identifier dict. Oh, hold up. Six errors, minus 42. Has anybody done this function? Anybody in chat done this function? Bool check. I'm done with this. I'm over it. Like, this is just stupid. Like, this isn't helping us at all. Can you, like, give us some suggestions? Or, like just telling us line 42 isn't doing anything to help us learn. Like, it's just... Sitting here staring at this isn't doing anything. Your check function, you see that you've added a condition and check node is not equal to. This is good to check. Keep in mind the check function is only valid with words. So I keep failing on the stir case comp for debug 50. Hey Tim, we're still working on this. We still have this thing. Glog for more information. Line 42. It's this thing here. What is going on with the stir case compare? This is the only thing that's failing is this line 42, and I don't get it. Why? Six errors. So this is the error we get, guys. Let me go to this stupid freaking...
The last step to completing in the check function, import the word is in the dictionary. It's going to be a compare. Well, let's take a look at an linked list. Well, you could imagine that I could set up a variable called cursor, for example, which initially is a pointer to the first element in the linked list. And I might check, is that the word I'm looking for? And if it's not the word I'm looking for, then what I'd like to do is take the cursor and move it to the next node in the linked list. Well, where is the next node stored? It's stored inside of the next field, inside of the node that I'm currently looking at. So if I were to use syntax like cursor equals cursor arrow next, that would mean take cursor and set it equal to whatever cursor's next stir case comp function, which is similar to stir comp, which compares two strings, but stir.
Well, the current node we're on Hall monitor, that's what we're trying to figure out. We don't know why, dude. We're beginner. This is a beginner course. Looks like you're trying to use a variable that might not have a value. Take a closer look at line 42. Okay, so let me just say if so what if the word is nothing? I thought I'm doing that here. Else return false. Return true. Say that this wasn't it. Move to the next. You don't ever get it. Return false. Still failing this. Your updated check looks quite hard. Unsign it. While dig if stir comp. Imagine indexing that's null. I'm sure that would cause problems. So then I'll just do this. If dict node pointer to word is equal to null, it should never be null though. It says return false. But this won't work either. Right? It won't even let me compile because it's always equal to a null pointer if it's always false. Yeah, it says it in this error message. Uninitialized node work in load. If load fails to copy, if new node equals no return false. Dict node hash table. We trying to do this? If not word, return false. Unsigned int equals hash number word. Node dict equals this. This will never need. While it's not false, if dict node, this will never happen because word is never set to null. Dict node. So do you think we should allocate memory instead of using a hash here? We're going to the dictionary node. Oh, I hate this. I'm so over this. We don't even need this. Like, get at it. Like, we don't even need this. But this fails. Verify, what to verify and load. What to verify. This version of check is clean and logically correct. However, since you're still getting conditional jump, it's most likely in your load function. Specifically, it suggests that dict node word might have properly initialized in all cases. So in our load function, memory allocation, ensure that each node is allocated using malloc. Ensure that you always copy a string from the word. So we have new node, size of node. If new node is equal to return false, stir copy new node pointer to word. So set if you're skipping. Let's review the load function. Remove the malloc for hash table. Load malloc size of node. I don't need to declare a malloc size of hash table. Unsigned int if stir copy new node next unsigned int hash num on word. Stir copy node word. So let's just remove this altogether. But this is buffer. Assign it hash buffer for here. We don't need that. Okay. Assign it hash buffer. So we're not accessing this anymore. Unsigned int new node. Hash buffer new node. So node, if it's false, return false. Stir copy new node unsigned int. If we don't need any of this. table hash equals new node. And then remove temp underneath temp. Okay, that solved it. So it's happening in here. Ah, we're done. All right, we felt so anticlimactic. It's just like when you do it for so long, it just feels like, oh, finally. So it's like whatever. So we're scanning, we're creating a new node. If that new node is null, we're returning false. We're saving node memory. We're copying it and setting the new node. We're copying the word and setting it onto buffer. And then we're going new node next, null. We're adding each word to the hash table by doing it here. New node goes to the hash table. Table hash number new equals new node. Let me increase the count. Oh, like I don't even realize what's going on anymore. My brain is like numb to this problem. Like I was really following it, honestly, up until I started getting all those errors. And then I started just having to, I got lost. I was following it really well up until that last function of check issues. The problem wasn't with our malloc though, Hall. So you're wrong on that front. We already were reserving our memory appropriately within this function here, within our load function, right? But we just had that condition that was, you know, we were calling malloc again for a hash table or whatever when we already were declaring hash table with up in here. So we just had to declare a size of, or malloc reservation in memory, the size of a node for this struct. Sweet. So then what's really going on here though? The stir copy, we're creating a copy of the new node's word and putting it onto buffer. Oh no, we're taking the copy for the word from buffer and putting it onto word. And then we're saving the node's next value as null. We're getting the hash value of this word. We're going to that hash location. We're setting the new node.next there. The null value is equal to this here. Right, the new node.next at this location. So null, or whatever's at this location, is going to be set to new node next, right? Because we're inserting in, moving that over, and then setting what was there as the new node. Perfect. So in the check, we just do this. Okay, so it wasn't it was telling me line 38 was wrong, but it was not line 38. It was getting a word or a dict word here, word from another function, and it was within our load here. All right, cool. I was doing really well moving on this problem up until that last, we were stuck on that bug for a good hour, trying to figure it out. Yeah, Hall Minotaur, man, this is a beginner course. You need to chill, dude. It's all right. We're learning. It's all part of the process. Cool. All right, let's move on here. We are done with this one. Let's go out of here. Let's go see what's next. Why does it do this? See, why does Mac do this? What is this? Like, what is this Mac OS? Like, why are you doing this? It's just like so stupid. It's like it has so many, Mac OS has so many bugs with its file windows. You got this, Insomniac. You got this. If I was able to grind through this one, you got that, man. You got that for sure. Wallpaper, yeah, that's Oregon. It's the Oregon coast where I'm from. So let's go see what the next. Okay, next week is Python. Oh, easy peasy. Submit hello in Python. This version of Mario, cache, readability, DNA. Oh, come on, this is gonna be easy. In a file called hello, and implement a program that prompts user hello. So easy. Yeah, right, Tim? This is Python week is gonna be so easy. Woo! Hopefully, I say that now, knock on wood. All right. If you guys are enjoying the stream so far, throw it a like. We just completed that one. What should we do? What should we do? Should we break here for like 25, 30 minutes and then come back and start with, our normal stream of DSA and Python and approaching 1.3? Are we really? Is the Python week really easy? Ah, the Eagles have won the Super Bowl. If you guys care about that. Congrats to the Eagles. I'm actually kind of happy that Jalen Hurts got a Super Bowl. He's a pretty good player, and I kind of feel bad when they keep losing over and over again. It's like, oh, dang. Chiefs have had it enough. It's time for somebody else to win. Not that I really care. I don't watch football at all. All right. What should we do next, guys? We knew that result 3 hours ago. Bro is trolling. I didn't watch the game. I was studying. The grind never stops. All right, let's go to neat code here. Let's see. I don't really want to do one of these right now, but let's see. Stacks, min stack. Design a stack class that supports push pop, get min operations. Push the element value of stack pops, get min top. Design a stack class that supports the push pop top and get min operations. Min stack initializes the stack object. Void push. int value pushes the element value onto the stack. Pop removes the element from the stack. Gets the top element. Retrieves the minimum element in the stack. Each function should run in O one time. So we need a structure to handle this. So if we have to get the minimum value, okay, so let's do this. Stack is equal to some empty array. Push stack dot append val. Pop if length stack min equals none, minimum equals none. Append if stack, if not stack, minimum equal to val, right, if minimum val is less than minimum minimum is equal to val. So if not stack, so if the stack is empty, right, we're going to set the minimum value equal to the current value provided, or, right, else if value is less than minimum, so else, actually, no, so if value is less than minimum, so elif value is less than minimum, update minimum. Minimum is equal to value, and then append the value onto the stack. Retrieves the minimum element from the stack. Does it retrieve the index? Return 0. Or just returns 0, okay. Go to the solution option. Right, so if the stack is empty, we have no value, so we're going to make the minimum value equal to that value provided. Elif if value is less than minimum, right, then we're going to make the minimum equal to that, and we're going to append the value no matter what. Pop, so if not stack, return none. Else stack.pop, right? top would give us reference to the first element. So if not stack, return none, else return stack -1, and then get minimum, return minimum. So let's think about this. If the stack is empty, set minimum to the new value pushed onto the stack. Elif value so we say actually else elif value less than minimum. Let's see this. Let's just return null, min stack. Oh, we have an array here. Stack is not defined. Self.stack and self.minimum, right? If not self.stack, self.stack, self.minimum, self.minimum, self.stack, 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 self.getmin. Min stack has no attribute tack. Oh, did I delete something? Self.stack. Name error. Minimum is not defined. Ugh, I have it everywhere. Okay, hold on. Less than minimum. So this would be self.minimum. Now we run. Okay, we're getting something here now. Null, 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 0, null, 2, 0. For get min. Oh, so if it gets popped out of the stack, okay, so we need to return the index value of that one for the minimum thing. Mini equals self stack index 1. Index -1. That would throw me a value error at the start because you have nothing in here. So if we append a value, if we push something on, so do we need to keep track of a length of a stack then to keep track of indexes? So let's say self.length stack length is equal to self dot stack length of self dot stack, right? So if we push so instead of doing this, we'll set it equal to 0. If we push a value on, we increase the length. Plus 1, plus equals 1. We increase the stack length by 1 if we push something onto the stack. But then we need to save the index if this is minimum. Minimum index is equal to none, or index none. So minimum if the stack is currently, we set the minimum. Oh shoot! I just creased that page big time. Oh no! Come on, pull back over. Yeah, the minimum is popped. That's what we're trying to work on now. So what we're trying to do, if the minimum gets popped, we need to keep track of its index of the minimum. So stack length equals 0. So minimum what if I go self dot stack dot append val, then I increase, then I set minimum, or self dot minimum index is equal to stacked length will increase, and we'll set this equal to self dot stack length, right? So the length will increase when we append, and we'll set the minimum equal to that increase at that point in time, right? For if it's empty, right? If it's less than, we're going to do the same thing, right? If it's less than, we're going to do the same thing, append the value, increase the stack length, save the minimum at this length, like that, right? So self dot stack index minimum length, no minimum index. So if we have an empty stack, we're going to add the value, increase the length by 1, and save that as the minimum index. If the value we're adding is less than the stack at that minimum index, we're going to add the value, increase the length, and override the minimum index to be that new index. So then, and then we're going to, that's it for that. Else, right, else we'll just add the value and increase the stack length. like that, right? So rather than taking the stack length at every single time, I'm just using a counter for the length. So I don't have to, you know, take a length at every pass of an append or pop. I can just use a constant counter. So then, if the stack is empty, return none. Else, pop the value. Else, right? If stack so the minimum index will be, if this is the last, if the minimum is the last one in the stack, the length will be 1 greater. So if the stack length minus 1 if stack index stack length minus 1 is equal to stack at so actually we don't even need to do this comparison of the value, we can just do the index comparison. So if the stack length minus 1 is equal to the stack minimum index self dot minimum index self dot stack length, that if it's equal to the minimum index, we're going to pop off the value oh shoot. How do we save the previous minimum? Oh, no. So we have to save a previous minimum too? Shoot. Self dot stack index minimum index. So if the stack is empty, return none. Else, if the stack has a length minus 1 equal to the minimum index, oh shoot. I don't want to check the solution option. Sorry, I'm not going to do that. If you want to optimize time, you need to sacrifice for space. So you're saying that, oh, I should store a list of minimums, basically. So what happens if you pop off the minimum value, you have to have a reference to the next minimum somewhere. Oh, shoot. Oh, shoot. So we have stack length 0, minimum index equals none. If we add an item onto the stack, hall monitor, that's what I'm doing, dude. I'm talking through this. You're saying the same things over and over again, dude. I'm working through this out loud. All right, so if we push an item onto the stack, If the stack is empty, we're going to add the value, increase the length of the stack by 1, and set that value as the minimum, right, index. The index, right? So the length becomes 1, index minus 1, right? If the value is less than the stack at its current minimum index, so if I add values on, I need to save a previous and another previous and another previous. So if I push something onto the stack and I pop it off into C. So should I save the index values and the minimums in another array, or like in a dictionary, like a key value? Oh shoot. Right, so how can we, for the get min, how can we determine if you had popped off the minimum? So if a stack is empty, return none. Else, if the length minus 1 is equal to the minimum index, so you pop a value. Oh, my brain stopped working. We've been doing this for too long. Yeah, trash. We're trying here. We are trying here. So what do we need to do in the case where we pop off our current minimum value? So if we have a stack of numbers, let me pull up my whiteboard. If we have a stack of numbers, let's say we push 5, we push 4, we push 6, we push 8, and we push 1. Well, minimum is going to be 1, right? So if we pop that off, our next minimum becomes 4. How can we save that? So if we push 5, this becomes minimum. If we push 4, this becomes minimum. If we push 6, this doesn't do anything. Push 8, this doesn't do anything. So we have to keep some sort of sorted order. No one's getting upset, my friend. It's just you're kind of saying the same things over and over again, that not really providing any, help, as you are saying. I appreciate you being here, though. You're just telling me to talk through it. I'm talking through it. Like, this is really not helping at all. Okay, so if we push the 8, so then if we push onto the 5, that becomes our minimum. So then do we need to keep a sorted array as well? No, I feel like I'm doing this incorrectly. So if you push on the 5, we push on the 4, we push on the 6, the 4 becomes our minimum, index value at 1, 0. This doesn't do anything, this doesn't do anything, but we get a 1 here at index 4, that saves as minimum. We pop. So how can we keep track of previous minimums? How can we keep track of previous minimums? Zainab says, elif max, elif value is less than self-stack minimum index. Self-stack minimum self-minimum index equals to self-stack dot length. Yeah, we have that here. But you have to add the value first. Could you possibly push the minimums onto the stack as well? What do you mean, Jaws? Could you clarify? Could you possibly push the minimums into the stack as well? Well, we are pushing the minimums on, but what happens if we pop off? So it has to be in constant time. Every function has to be in constant time. So we have to keep track of this within a variable as we're appending values on. Push, get min. Pop, top, get min. So do we need to sort? For each value, we have a minimum and push that tuple into. For each value, we have a minimum and push that value onto that tuple. I'm sorry, I'm not following you, Jaws. You're talking about tuples now? So how can we save? So let's say we come across a 5. That's our minimum. Okay. We come across a 4. That's our new minimum. We pop off the 4. We need to somehow know that the 5. So what if I have like self dot minimum indexes, which is an array, indices, right, which is an empty array. We go so if we come across no value, we increase the length of the stack by adding the value, set the minimum index equal to that place, equals to, oh, I got you, hold on. So we'll say minimums. How about minimums? And then we say increase the length. We append self.minimums, the value. So we'll add the value to the minimums array if it is the minimum. So if the minimum is here, we're going to add the value, creating another stack basically. And the value. So and then when we pop the value, if self.stack value -1 is equal to minimums -1, pop the stack and pop off minimums as well. Okay, so we're creating two stacks basically, one main stack and one just for our minimums. If the stack is empty, we add the value to it, we increase the length by 1, and we add the value as well to minimums. If the value is less than the stack at minimums index -1, the most recent at minimum, right, then we'll append the value to the stack, increase the length of the stack, and also append that value onto minimums. Else, right, it's not less than, it's greater than, so we'll just append the value, increase the stack. Pop, however, if the stack is empty, we return none. Else, if the stack at -1 is equal to the stack at minimums -1, meaning that we are trying to pop off the value that is our minimum, current minimum, then we will pop both of them off. Elif, else, stack dot pop, self dot stack pop dot pop, right? You don't need to pop off minimums. You return a reference to the negative first value, and then you return minimums -1. If self dot minimums, turn that, else turn. Right, so what if we keep two stacks, one with all of our main information and then a separate stack for just pushing on our minimum values? And if we come across a case where we're trying to pull off from our main stack a value that happens to be the last value or the most recent minimum appended to our minimum stack, then we're going to need to remove both of them to have our next minimum take its place, right? So what happens if we run this? Elif elif. Whoop. All right, we accepted that case 1. No. Your output was min, but the expected return type int. No, -3, -3. Oh, shoot. Your output was minimum, but not expected return type. But the expected return type is int. Type error. Your output was none, but it's int. Was it not like returning none? This returned get min of -2 though. So what if they pop the second minimum? Well, wouldn't that should still take place with our stack of minimums? Take note, your solution doesn't handle if 2 minimums are pushed onto the stack, but then only one of the minimums popped. What? So let's say I push on 5. Well, 5 becomes minimum in my 5. I push on 6, that nothing happens. I push on 4, 4 goes onto my minimum. If I pop off 4, I pop off 4, leaving my minimum still as 5. Oh, 2 same values. So then you're saying, oh, so you're saying I need to be less than or equal to. Right, you have to be less than or equal to the minimum value, meaning that you can be the same as the current minimum value. So then less than or equal to, you have that minimum value, pop, if it's equal to. Self.stack should be a list so that it can store elements. Here, by mistake, one has been assigned, which is an integer. My stack is a list, my friend. So is that all that we had to do, was just say less than or equal to minimums -1? So that if it's also the same, so in this circumstance, you push on -2, you push on -2, you push on -3, you push -3, you pop -3, it should give back -3. So if I submit here, woo! We got it! Yeah, let's go! That one was easy. Let's go. Well, not crazy easy. We had to think about those little edge cases, but I got all the main kind of functionality going, except for that minimum. I had to kind of think about it. So by creating 2 stacks to push our minimums onto as well, we can keep track of that in constant time. So if we could have had our minimum run in O of n time by just looping over and determining the minimum at that point, but we have it we sacrifice a little bit of space by creating another data structure of another stack for our minimums, and then that makes our minimum in constant time. Woohoo! Thank you guys. We solved that one. Awesome. If you guys are new here, thank you so much for joining me here. My name is Michael. I'm 26 years old. Been teaching myself programming for a little over half a year now with you guys. I'm along my side. I really, really enjoy all you guys coming here. Hall Minotaur, Jaws, Alex N, Zenab. You're awesome. Thanks for coming in here and helping me out with these problems. Tim, Ryan, SSLO, Insomniac. I think I already said Hall Minotaur. You're awesome. Thanks for coming in. Who else was here? Von Trell. You're awesome. Word challenge. Cool. So we finished week 5 of CS50X, and then we also finished a elite code problem here for the stacks. Now, I was eyeing this problem for a few weeks now because I was like, oh, I think I could do this one, but I just didn't really want to do it because it seemed kind of long. But it actually wasn't that hard. So I'm glad this one was cool. This one's nice because it's just going to show you that reading that we're doing within our DSA in Python about stacks is working. So it's really, really awesome. Hey, Handle Things, welcome in. How's it going? Appreciate you for joining me here. Welcome back in. We got a ton of new members over the weekend. I commented on this. Yeah, Jaws. Jaws suggested that in order to keep things running fast in a constant time, we had to give some kind of memory. So I was trying to handle things by just having things handled in single variables, but I needed to access more past information. So that's why I had to store minimums within a stack as well, so I could keep track of all the previous minimums and return those back to us as well. Anyone know if this was a problem? This is a problem in LEET code. LEET code. Let's see. Minimum stack. Self.minimum index equals 0. Let's look up here. Minimum stack. Here we go. Oh, cool. Okay, so it is. Let's go ahead and copy this in then, I guess. Let's go here. Let's bring this over like this. Bring this over here. Copy this in. We want Python. Right. Let's go here. Let's take these guys. Pop. Top. And get min. I guess does it want to return none if you have no min? All right, let's see here. Woo! Sweet. Yeah, we solved it. Fastest LEET code solved ever. Nice. All right. So we got 11 milliseconds on that one with our solution. Beats 25%. Memory, I beat 60% of people with memory. Interesting. So let's go back to the neat code one and let's go to the solution here. Brute force. So they say they call self.stack, append value, pop value, return -1, get minimum, temp, mini. They call wall length, so they loop over and pop off the mini value and return mini. So then in 2 stacks, stack, min stack, stack append value, then he appends it to the minimum stack. Interesting. So he doesn't even do this other check. Val, min. So he has a min function? What is this min function? Oh, minimum between the value, stuff like if, else val. So take from the mini stack. Okay, so he wants you to determine the minimum value between the mini stack -1, if there is any, or the value, else just take the value as the minimum and append that value onto the mini stack. Okay, so rather than creating two different variables, he just determines which one or the other. And I do two separate appends. But he also calls pop to stack and min stack as well. He's calling a get min. If self min else return. So I don't even need an else really. One stack, minimum stack. Cool. It's interesting how there's like a lot of different ways to solve them. Right. All right. Sweet, you guys. Well, thanks so much for joining me today. We streamed for 4 hours today on this beautiful Sunday, February 9th, 2025. We completed week 5 of Harvard CS50X this week. It was really, really cool getting into memory, learning about pointers. It was a lot of new learning that I had to do, with our note taking. If I pull it up real quick. Right. Week 5 was all about pointers and memory. So we had to get a lot of new information regarding, managing these pointers with also dealing with things like trees and linked lists and structures, right? Having these pointers, be references, kind of like instance variables within classes in Python. So we talked a lot about, data structure. I'm sorry, week 5 was about data structures, but we carried over that pointer information by, having those data structures be saved in our memory via pointers and having to access them, somehow with their associated variables and whatnot. So it was a really cool and really interesting week so far. Got a lot of practice. Feeling comfortable, a little more comfortable with pointers now and memory. Still need to get better just about the overall handling of freeing up memory. I'm still not too great at that. I understand the overall concept that we need to free things, but sometimes it can be kind of difficult to keep track of everything that you're allocating. So what I kind of had struggles with is with the arrays that are being generated. You don't have to free those, but if you call malloc, you have to free those, from what I understand, at least in that problem that we worked on in week 5. So anyway, you guys, thanks so much for joining me here. If you had a good time and enjoyed your stream, thanks so much for being here. I really, really appreciate all you guys being here and helping me out in the chat. Just helping me out, giving me suggestions, encouraging me on. All of you guys were really awesome. Josh, Winhong, Zanab, Alex, and Hall Minotaur, you were great, especially helping me out with those problems. Trash Ketchum, you're awesome. Tim, Ryan, Insomniac. But anyways, guys, I'll be back tomorrow for more, or maybe I'll do another session later tonight. I'll take a break for maybe about an hour and see where I'm feeling things. But I gotta take my dog out and hang out with her for a little bit and just kind of relax and let my brain chill after we did some hard problems here. But it was a very successful study session today, over 4 hours of just straight problem solving in programming, different problems, whether it be in CS50X or NEET code. So thank you guys so much for being here and joining me. I will shoot an announcement at the Discord if I go live again later this evening for just a live coding session working on the project or something, just very chill. But anyways, I'll see you guys tomorrow.